Okay, let's try this problem. Ammonium hydrogen sulfide decomposes into ammonia gas and hydrogen sulfide gas through the equilibrium reactions shown. If a sample of solid ammonium hydrogen sulfide is placed in an evacuated flask at room temperature, calculate the total pressure in the flask. Okay, so our question mark right now, I'm going to pause, is the total pressure in the flask once equilibrium has been achieved. They give us a Kp value of 0.18 at that temperature. So our Kp happens to be 0.18. They give me a Kp value. Let's go ahead and write the Kp expression. The Kp expression for this reaction will be our products. Since we're dealing with pressures, let's write pressure of NH3 raised to the first power times the pressure of the H2S raised to the first power over nothing. It's a solid. Leave it out. That is our equation. Now, for Kp expressions, we need equilibrium pressures. Let's go ahead and look at our ice table. They start with a sample of solid ammonium hydrogen sulfide. How much? I don't know. They just put some solid in there. They did not put any initial NH3 or H2S in the container. This tells me that I have to go in the forward direction in order to reach equilibrium. I'm going to take away from the left. I'm going to add to the right. How much? Well, let's call this one X. And if I take away X from here, it's a 1-to-1 ratio. So I'm going to add X over on the right. And if I add X here, it's a 1-to-1 ratio. I'm going to add X here. So at equilibrium, the ammonia is X and the hydrogen sulfide gas is also X. So right now, I know 0.18, the equilibrium value, equals the pressure of NH3 at equilibrium, X, times the pressure of our H2 at equilibrium, that's also X, or together, X times X is X squared. So we can go ahead and find the value for X by taking the square root. If we take the square root of 0.18, we get a value of X of 0.42 atmospheres. So at this point, I know my equilibrium pressure of ammonia is 0.42 atm, and I know the equilibrium pressure of hydrogen sulfide is 0.42 atm. So I know my equilibrium pressures, but that's not what they want. They want the total pressure. So where does the total pressure come from? Pressure comes from gases here. We have two different gases in my container. The total pressure will come from the pressure of the ammonia at equilibrium plus the pressure of the H2S at equilibrium. Now those two together add up to my total. What's this one? 0.42. The H2S at equilibrium is also 0.42. So P total is going to be 0.42 atmospheres plus another 0.42 atmospheres. And if you go ahead and add those together, the total pressure in the container, 0.84 atmospheres. I hope that helps. Take care.